Hey 7th grade, welcome to your solar system lecture. This is going to be fun. Space is really interesting, astronomy is really interesting. And let's get started. Pull up slides if you have not. So let's talk about what a solar system is. A solar system is everything that revolves around a star, everything that orbits a star. And the main star in our solar system is our sun, the big thing you look up at in the sky. The first person to say that we revolved around the sun was Copernicus, Nicholas Copernicus. He was an astronomer. For years and years and years, just like how we thought the Earth was flat, we found out that was wrong. We thought that everything we saw in the night sky revolved around the Earth. But many studies that Copernicus did and other scientists did found that the solar system, or all the planets, revolve around the sun. So how did this solar system and everything in the universe come to be, scientifically speaking? This is where the thing called the Big Bang Theory comes into play. No, it's not just a comedy television show where there are a bunch of nerdy scientists. It's an actual theory posited by mainly physicists. Physicists are the ones who mainly studied all this. Basically, the Big Bang Theory states that 13.8 billion years ago, everything that made the universe existed in the size of something 1,000 times smaller than a pinhead. And what was in there was a bunch of gas. It was extremely dense and extremely hot, hotter and denser than anything we've ever recorded. And something, the right conditions, made it explode. And in that instantaneous explosion, it was a supernova, and everything went boom, and the universe came to be. Planets started forming, asteroids started forming, dark matter, black holes, you name it. There's a lot of studies still going into this. We're not sure of the complete exact conditions in which make this happen. We don't know if it could happen again. Who knows? This theory also states that the universe is ever expanding. It's getting bigger and bigger and bigger. All right, so let's talk about the sun. That glowing thing in the sky that makes this lighting really annoying. Okay, so the sun is the center of our solar system, as I said. It's called Sol from Latin, which means sun. And it is a dwarf star, meaning it's not the same size as a regular star. Orion, the star in the constellation, is a lot bigger than that one, than our sun, but it's far away. It's outside our solar system. And so it is actually the largest object in our solar system, and its gravity is what makes everything stay in orbit around it. It's so big that its gravitational pull is so large that it can keep everything in its little orbits. It provides the light and heat we need to survive. And an interesting fact is that its core can reach up to 18 million degrees Fahrenheit, which is really hot, and I'm going to be nice and not make you convert that to Celsius. The sun's really important. It keeps the solar system together. So let's switch to slide 4, the order of the planets. You probably know this, but here's a refresher. It's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Pluto's not a planet anymore. We'll get into it in a minute. It makes me sad. So, to remember the order of the planets, there is a popular mnemonic device that people used to use when Pluto was a planet. That one is, "My very excellent mother just served us 9 pizzas." To tell the difference between the M's, between Mercury and Mars, Mercury has a Y in it, that's why it's my. But because Pluto is not a planet anymore and you don't count it, there's only 8 planets now, there aren't 9. You could use "My very excellent mother just served us nachos." Whichever one you want to do. If remembering Pluto helps you, go for it. But just know there are only 8 planets in our solar system now, not 9. Speaking of solar system structure, if you hear me use the terms inner and outer, inner solar system is everything from Neptune into the sun. outer solar system is from Neptune out. Okay? So Pluto's in the outer solar system. It's still part of our solar system as a whole, but it's just in the outer reaches. An interesting feature in our solar system is the asteroid belt. It's between Mars and Jupiter, and it's basically just this giant ring of a bunch of asteroids, rocks, minor planets, lots of stuff. And it's a lot of many irregularly shaped objects. Most are asteroids, but some of them are minor planets. They're dwarf planets or things that can't be considered a real planet, but they're close. There are 4 main bodies that make up about half of the mass in this asteroid belt. I won't tell you what they are because that's part of your homework. Let's move on to slide 6 and dwarf planets, where we talk about our friend Pluto. We still love you, Pluto. It's okay. All right, so dwarf planets are small planetary-like objects that don't dominate their neighborhood or their orbit. They haven't cleared it. And there's some other technical criteria they don't meet, but I won't bore you with it because you don't need to know. They're just basically almost planets, but not quite. Pluto is the best example that you may know of. It got demoted in 2006. For years and years and years, up until 2006, everyone thought, oh yeah, Pluto's a planet. There are 9 planets in our solar system. But upon further studies and movements in research about Pluto, we realized, okay, it doesn't quite qualify. Maybe it's something that like was knocked out of orbit. Who knows what it is? But one of the biggest players in getting it demoted was that Pluto itself has an odd orbit and where it's placed in the solar system, which we'll get into in a little bit. There are 5 known dwarf planets in our solar system, and they are all in the outer system, so outside of Neptune's reaches, except for one. It's Ceres, and it's in the asteroid belt. So we talked about how Pluto has an odd spot in our solar system. It's actually in something that's called the Kuiper Belt. And this Kuiper Belt is about 50 astronomical units from the sun. And an astronomical unit is the distance from the center of the sun to the center of the Earth. We just use that as our standard unit for measuring anything because it's easier to base it off something we know, like the Earth. And so it's 50 of these astronomical units all the way out in space, and it holds many, many, many small celestial bodies that are from when the solar system first formed. Lots of asteroids and small planets. These things are called, small planets. A lot of ice out there because it's very cold. And more things that we haven't quite studied yet. So, slide 8, what's beyond the solar system? You all know that we live in the Milky Way galaxy, and it's estimated that there are between 100 and 400 billion stars, so like the sun, but bigger, 100 to 400 billion of those, more than 100 billion planets, and we have confirmed the existence of over 4,000 exoplanets, so things that are not inside our solar system, even the outer reaches, but outside that. So we've confirmed that there are over 4,000 other planets out there in just our little galaxy, our little corner of the universe. You'll see in the picture there that that first picture on the top is a computer-generated image of what we think the galaxy looks like. We've been able to use a lot of science to come up with imaging. And the picture on the bottom is actually an arm of the Milky Way that's viewable from Earth. So in some areas on Earth, on very, very clear nights and places with low light pollution, you can see the Milky Way. It's really cool. Maybe one day you'll get to be somewhere where you can see it. So let's move on to slide 9, our last slide of content. What else is out there? We don't know. Well, we know some. Mainly a lot of dark energy and dark matter, and a lot of empty space. Guess what? There's space. In space! Who would have guessed? So the contents of our universe, as far as we know, is actually 95% dark matter and dark energy. The other 5%, all the planets, all the stars, all the asteroids, everything else that we know of. And that's just 5%. And think about the numbers I told you. There's 100 to 400 billion planets in our galaxy alone. So that tells you how big the universe is, and it's constantly expanding. So our nearest galaxy is Andromeda, and that's still multiple light years away. Like, we're not getting there in my lifetime, sadly. But it's pictured there. That's actually the clearest picture the Hubble telescope's been able to get. And so far we haven't found any livable planet that maybe we can move to if we wanted to go move across the galaxy. We haven't found anything yet that could support life. But we found some promising data of life in the past, like maybe there was an event in which an atmosphere changed and there's no life now, but there could have been life before. And all in all, we're still exploring space. We still have a long way to go. My dreams of being a part of Star Trek are so far away, but it's fine. As people always say, born too late to explore the Earth, but too early to explore the galaxy, so what am I going to do? And apparently it's teach science to you guys. Yay! So if you look at slide 10, you'll see your homework, and I just want to explain it to you really fast. So you'll see that little link there. It's solarsystem.nasa.gov. And it gives you an interactive view of the solar system. It's like a map. And use that to answer all the questions. So how many astronomical units away are Jupiter, Mars, and Neptune from the sun? From where does Jupiter get its namesake? What are the 4 major bodies in the asteroid belt? Where's Voyager 2? What do the stereo spacecraft do? And what's your favorite planet? So what you can do is just go ahead and click on all the things in there and explore the solar system. Have some fun, answer the questions to me in an email, and have a good day.